Bismillahirrahmanirrahim. Laplace transform of unit step function and its applications. So, what is the Laplace transform of what is a unit function? Unit function is a function ut minus a is equal to it is 0 in some interval, and that interval is from 0 to a and 1 otherwise. This is unit step function. So first of all, we have to find the Laplace transform of this function, this unit step function. This is equal to integral from 0 to infinity e minus st and then the unit step function dt. So we see that we have to split the interval from 0 to a e minus st, and the unit step function is 0 over here, and then from a to infinity e minus st dt, and a unit step function here is 1. Okay, so this is 0, and we get the Laplace transform of the unit step function is equal to, if we take the integral, that is e minus st over minus s from a to infinity. So this give me, from the upper limit we get minus 0, and from the lower limit we get e minus sa over s. So this is the Laplace transform of the unit step function. This is the Laplace transform of the unit step function. Now we will use the unit step function in some notations, and then we'll in some function. Let's say we have a function f of t is equal to, this function is 2 in the interval from 0 to 2, and it is minus 1 from 2 to 3 and 0 otherwise, t greater or equal to 3. So this function can be written in the unit step function as, this is 2 minus 3 unit step function of t minus 2 argument, and then plus unit step function of t minus 3 argument. Okay, now we want to find the Laplace transform of this function. Laplace transform of f of t, so this will be equal to Laplace transform of 2 minus 3 Laplace transform of the unit step function t minus 2 plus Laplace transform of the unit step function t minus 3. So this will be equal to 2 over s, we know it, and this is 3 times e minus 2s over s, and this one is e minus 3s over s. So this is the Laplace transform of the given. This is an application of the unit step function to write a piecewise function in term of the unit step function, and then it is easy to find the Laplace transform of this type of function. Now another application is, we have to show that Laplace transform of f of t minus a and a unit function t minus a is equal to e minus as f of s, or e minus a is Laplace transform of f of t. Okay, so let's take the Laplace transform. Laplace transform of f of t minus a and the unit step function of t minus a. This is equal to integral from 0 to infinity e minus st f of t minus a unit step function t minus a dt. So we have to split into three parts, two parts from 0 to a e minus st f of t minus a, and the unit step function here is 0 dt, and then from 0 from a to infinity e minus st f of t minus a, and the unit step function here is 1. So this is the remaining. This integral is 0, integrand is 0, so it is 0, and we left with a infinity e minus st f of t minus a dt. Okay, so we take z to be t minus a, so this implies t is equal to z plus a, and take the limits. When t tend to a, z tend to 0, and when t tend to infinity, z tend to infinity. So we will change the limits and the functionality of the integral. So this is equal to Laplace transform of t minus a f of t, Laplace transform of f of t minus a unit step function t minus a is equal to from a to infinity e minus st f of t minus a dt. But we take z to be t minus a, and on this limit, this integral from the previous slide, we can write from 0 to infinity e minus s z plus a and f of z and dz, because the dt goes to dt, and we take the limits on the previous slide. So this is the overall integral. We can write this way: e minus sa integral from 0 to infinity e minus sz f of z dz, and we see this is the Laplace transform of f of t. So overall we have Laplace transform of f of t minus a unit step function t minus a is equal to e minus s a and the Laplace transform of f of t. This is the result. It can be written e minus sa and f of s. So this is the Laplace transform of this product function of t minus a and unit step function t minus a. Now, how we can use this um, t minus a unit t minus a should be equal to Laplace inverse of this thing. So now we will use this to find the Laplace inverse of some functions. So let's take Laplace transform, inverse transform of e minus 2s over s minus 4. So using let me call this one, using one we can write it uh, exponential ex, exponential 4t is the answer, but the t is translated 2 units back, so this is the exponential, and for the s minus 4 and a unit step function of t minus 2. So this is the answer of this um, Laplace inverse. Now let's take Laplace inverse of s over s square plus 9 e power minus s pi by 2. So this will be cos 3t, but the t is displaced by pi by 2 and a unit function of t argument t minus pi by. So we can use this in many functions to find the Laplace inverse of some functions with the unit step function. Okay, thank you.